today was not a great day. All right, lesson 36. We are learning to write and solve problems using proportions. And these proportions are going to be specifically involving similar figures in geometry. Okay, so this is very, very geometry-related lesson. All right, similar figures in geometry. All right. Now, so we need to define some things. We need to define what similar figures are. We already know what proportions are because we talked about proportions in our bell work, and we had some proportions in our homework as well that we just finished going over. But we do need to get a definition for similar figures in geometry. Does anybody know what the definition of similar figures are?
Isn't it like
there's like a big triangle and there's the same triangle, but it would be like 2/3 and then like 4/6.
Yeah.
Well, I mean, yeah, that what you just gave me as example. But how would you describe that? Same.
The same
shape,
shape,
but
bigger.
They're in proportion.
Same shape, but different. Like,
Same shape, but different. I mean, that's exactly right. So you guys came across just about exactly what I have written down here. If two geometric objects or figures are similar, that means they have the same shape, but not necessarily the same size. Right? And in your notes today, these first few notes are not going to make sense if you don't draw a picture of that. Draw it and label it. So go ahead and do that. So we're going to talk about the similarity statement is very important. How you state two things are similar is important. You can't just, go all willy-nilly and name the triangle one way and one triangle another way and say they're similar. The similarity statement communicates some things to us. All right, so this figure, we're going to take some notes about these two figures. Your notes won't make sense without it. Okay? Is everybody about there? Some of you are maybe trying to be a little too meticulous in your drawings. Yep. All right. So the triangles below are similar, and this statement right here is called the similarity statement. Okay, the way we read that is triangle ABC is similar to triangle DEF. That symbol there is the similarity symbol. It's not a congruency symbol. Okay, in geometry, there's a couple symbols that you'll use. You'll use equal. Equal means the measures are the same, right? Similar means that the shapes are the same, size isn't the same. And then there's this symbol. This is the congruency symbol. So if you put those two things together, what do you think that means? This means that they have the same shape and the same size. So this has to do with the measure, this has to do with the shape, this has to do with the shape and the measure. All right? So this is the congruency symbol. That's equal. That means the measures of the things are equal. This means the shapes are the same. And then equal measures and the same shape, we have what's called congruence in geometry. So congruence is a powerful statement. It's more powerful than just equal. All right? Now, these triangles are similar. So if we start out with this similarity statement, triangle ABC is similar to my stylus is not wanting to cooperate. Triangle DEF. Okay? This is a loaded statement. Because similar triangles have congruent angles and proportional sides. Right? That's a new fact. Similar figures have congruent angles of equal measure and proportional sides. Now, here's what that means. From this statement, from the similarity statement that we're given, we can make all of these assumptions without even seeing the figure. Without even looking at the figures that you guys have in your notes. I could tell you this similarity statement means that the measure of angle A is equal to the measure of angle what? D. It means that the measure of angle B is equal to the measure of angle E. And it means that the measure of angle C is equal to the measure of angle F. And we get all of that because the corresponding the corresponding angles of similar figures are congruent. And the way they are named in the figure, in the similarity statement, has to have the corresponding angles in the same position. Okay? We also know, just from the way this is named, that side AB divided by which side on the other triangle corresponds to side AB? DE. Now, I'm not looking at the figure anymore. You guys could look at the figure and tell which sides correspond. But AB divided by DE has to equal BC divided by what? EF. And the other two sides of the triangle are AC is equal to DF. Now look at the triangle in your notes that you wrote down. Are those proportions all true?
Yes.
What's AB divided by DE? It's 2. It's the length of AB divided by, it's 2, right? What's BC divided by EF?
2.
What's AC divided by DF? 2.
I see it.
Right? So the ratio of the sides is 2 to 1. That is called the scale factor, yes. Very good. It's also the ratio of the two sides. Now, we talk about scale factors when, a little bit more specifically when we're talking about a drawing. Okay? So we're going to skip some things that are in this PowerPoint in the notes because I want to kind of get to some things that are important at the end that we didn't get to in fifth period. So I want to kind of maybe go past some things because I think you guys know enough to do this. This is just a restatement of what we just discussed. They have sides and angles that correspond. Corresponding angles are congruent, and the corresponding sides are proportional. We've already stated that. And we've already stated all of these facts. Okay? Now, let's use this to answer some questions here. I don't know why this thing keeps coming up. My volume thing is in my way. I can't see what I'm doing here. Here's the similarity statement. This is extremely powerful, right? I can take this statement without looking at anything over here, right? I don't have to look at anything here for now. What assumptions can I make? Angle P is equal to angle W. Angle Q is congruent to angle X. Angle S is congruent to angle Z. And angle Y is congruent to angle R. So we can make all of those assumptions just because of the way that similarity statement is given. So the similarity statement has to be stated a certain way. All right, now we're going to use the properties of similarity. What are we looking at here? If we look at our 3 questions over here on the wall, what are we looking at? We're looking at similar quadrilaterals. What are the properties of similar quadrilaterals? Corresponding angles are congruent and the sides are proportional. So we have to use those. What are we allowed to do? We're allowed to set up proportions to solve. We're allowed to set it, those are the kind of things. These three questions that we ask regularly in algebra are extremely important in geometry. Okay? What is the measure of angle Q?
Hang on.
80. It's equal to this one, right? Because of the similarity. Measure of angle Q equals 80. The measure of angle W.
120.
Doesn't it have to be smaller?
No,
The angle sides are shorter.
Oh, the angles are the
The
same.
angles are the same.
Same shape.
I see it. I see it.
Same shape, right? Okay, so the measure of angle W is 120 degrees. Now, that's what you just said is a huge deal. What makes it have the same shape? The angles are the same, right? And if we change the proportionality, it would change the angles. Right? All right, now find the scale factor of PQRS to WXYZ. What's the scale factor between these two figures?
Isn't it, wait.
From this one to this one.
Is it 1/2?
Isn't it 4?
Or like 1
3 to
and a
2
half?
is
Like
1.
1.5.
It's the scale factor is 3 to 2. That is 1.5, but
I get it.
we want to give the scale factor as a fraction or as a
Okay.
ratio because I'm going to use that ratio to set up proportions. Use the scale factor to find the measure of QR. I really wish this said to find A.
That's what I was just
Okay.
on my paper.
And because you guys haven't done quite enough geometry to know yet that if you just have a segment without the segment thing over top of it, that means the measure of that segment.
But isn't B?
So what they want you to find there is A. Okay, so they're asking us to find A, and ZY is B. Okay, all right. Now I'm going to tell you that I want you to set up an equation to solve for these things and not just use logic. I don't want you to just. I'm not impressed by your logical ability to figure things out. I want you to know the process because the process is going to take you a lot farther than knowing the answer. So 3 to 2 is the scale factor. And 3 to 2 equals A to 5, right?
Oh, that's what we did last year.
Yeah, A equals 7.5, right?
Yeah.
Or 15 over 2.
Cool.
Okay? Now to find B, we still use the similarity ratio. All right? The equation would be 3 to 2 equals 6 over B, and that means 3B equals 12, which means B equals 4. Okay? Now, you could easily make these not solvable mentally just by making this something like A minus 7 or changing this into a proportion that's going to have to distribute like the ones that we did in bell work. So that's coming. Make sure you know how to set up these portions and make sure you know how to solve proportions to solve. Yes, Brooklyn.
Did you do 3 over 6 equals 2 over B?
Yeah, that's what I did.
I really would prefer you not do it that way. Now the proportion is the same, but are we using a property of the? Well, really not. You know, you want to go from one polynomial to the other polynomial. Okay, that's how you want your proportions to set up because that's the ratio. Right, so we want to use the scale factor. If I did 3 to 6, am I using the scale factor between the two polygons? Not directly, okay. I'm using a similarity there because that ratio will exist between those two sides. All right, now we're going to skip the next example because I need to get to, this is pretty easy because they tell us we have similarity. That means that x over 5.5 equals 10 over 4, and you can set your proportion of it. All right, now scale drawings, same thing. Scale drawings are similar figures. So let's look at this example 3. A desk is designed to have 3 drawers on the right side. In the scale design drawing, the width of the drawer is 4 centimeters. So this is the width of the drawer in the drawing, 4 centimeters. If the scale of the drawing is 1 to 7, how wide will the actual desk drawer be? It's 28, right? But what's the ratio and what's the proportion you would set aside? 1 over 7 is my scale factor. That equals to 4 over X,
Oh, X, sorry.
right? Or whatever, A or D, whatever you want to put there. And then you cross multiply and solve it. So we're using similarity of figures to do this. All right, now this next thing is a little bit more complicated. You're going to need to write this down. If similar figures have a scale factor of A over B, then the ratio of their perimeters is also A over B. The ratio of their areas would be A squared over B squared. And the ratio of their volumes is A cubed over B cubed. Hey, babe. Okay? This is a big deal. Very, very, very commonly misunderstood geometry concept. Okay?
These variables are confusing me.
Do what?
All these variables are confusing me.
Well, it's just 2 variables.
Well, like when they're writing so many times, just like. Wait.
Yeah. So you have the scale factor as A over B. Let's put this into context. Let's say we have 2 rectangles. Similar rectangles with scale factor of 2 to 5. Does that communicate, right? The scale factor of the 2 rectangles is 2 to 5. The scale factor of their areas would have a scale factor of, or a similarity, a ratio of. Their areas would have a ratio of. I'm trying to rush to finish. The ratio of their areas would be.
4 to 25.
4 to 25, yeah.
Yep, would be 4 to 25. And if these rectangles were made into 3-dimensional figures, similar figures, like prisms, the ratio of the volumes would be
8 to 1 to 25.
8 to 125. All right, so that's an example of this. All right, let's just take this one step further. If we were dealing with circles, one circle has a radius of 1, the other circle has a radius of 3. So 1 to 3 is their circumference ratios. What would the ratio of their areas be? 1 to 9. The ratio of their volumes, if we turned them into spheres, would be 1 to 27. Okay, so that's what we're looking at with that concept. Your homework is there.
Oh, homework. I can write that down.
Write this down because I haven't put the syllabus on learning yet, but it'll be up there before the end of the day.
This is lesson 36, right?
Thanks, guys.